Namaste. Welcome to the course on optical fiber communication. In this session, we'll be covering the introductory part of optical fiber communication. Myself, Pallavi P. Kirkar, Assistant Professor in Electronics and Telecommunication Department at Goa College of Engineering. So let's see the contents for this session. You will know what is the optical fiber communication, what is the elementary communication link, what are the major elements of optical fiber communication, structure of optical fiber, and advantages of optical fiber communication. So, what is optical fiber communication? In the simplest way, if we have to define it, it means that it is a method of transmitting information from one place to another by sending light through an optical fiber. So, what is the need of an optical fiber communication? If we consider the rise in internet usage in India, over the past few years, it has grown at a very fast pace. The people's need for communication has increased. The amount of bandwidth required has increased. So if we consider the scenario for last 10 years, we used telephone coaxial copper cables, VHF and UHF radios for communication and data transfer. But these mediums could not support the ever-increasing bandwidth demand. So it was only when the optical fiber came into picture, large amount of communication bandwidth became economical and easily available to everyone. So, when we are trying to understand what is a optical fiber communication, we have to see what were the traditional optical communication links. So here is the elementary communication link. You have three components: transmitter, transmission channel, and receiver. So how the communication happens over here? Information is provided to the transmitter, which encodes the information and passes it over the transmission channel to the receiver, which decodes, restores the information and passes it on to the destination. Now here in this communication link, the communication takes place in the form of electrical signal. The transmitter takes in electrical signal, the transmission channel transmits an electrical signal, and the receiver receives an electrical signal. So now we can go to a optical fiber communication system wherein you have again a transmitter, a receiver. In addition to that, you have a optical amplifier, and the transmission channel here has now been replaced by optical fiber. Now what does a transmitter do? The transmitter has to take the data as electrical signal, which converts it into light with the help of a light source. The optical fiber coupled to the light source guides the light through it through a process, or the principle behind light guiding through the fiber is called as total internal reflection. Until this signal reaches the receiver, the receiver the signal has to be converted back into electrical form, because at both the ends what we have are the electrical devices which can accept only electrical signals. So the most important part over here in this communication link is the optical fiber, which guides the light, which is guiding our information in the form of light. So what is the structure of fiber, or how is the structure of fiber constructed, due to which light can be guided through it? So the fiber basically consists of three parts: core, cladding, and buffer coating. The core is a cylindrical rod made up of glass or plastic. Light propagates to this core of the fiber. Most of the light is propagated to this core. Cladding is made up of dielectric material, either glass or plastic, and performs a certain functions. Now what will be the basic function is, it has to restrict the light within the core. That is, it has to protect, it has to add mechanical strength to the core. And you have a buffer coating which provides an extra protection for the signal. Now we'll try to understand what is total internal reflection. So here we'll define a term called as refractive index or index of refraction. The index of refraction of a medium is defined as speed of light. It is the ratio of speed of light in vacuum divided by the speed of light in medium. Where C, if you see, it's N equals to C by V. C is the speed of light in vacuum. V is the speed of light in medium. N is called as the medium's refractive index. Here you can see, or you can have a gist of how the index of refraction varies with the mediums. So total internal reflection can be explained by this graph over here. What you see over here is the incident ray. Incident ray, when it strikes the boundary at boundary of the medium, it divides into two parts. One is the reflected ray and one is the reflected ray. So the reflected ray goes inside the medium, reflected ray is outside the medium. If you see the medium, this boundary is separated by a medium wherein the first medium is having a refractive index of 1.5, the second one is having 1.0. The second one is called as a rarer medium, the first one is called as a denser medium. So if you see in the second figure, as the angle of incidence increases, the angle of reflection with respect to normal also increases, and incidence is equal to the reflected. In the third figure, if you see, this angle is called as a theta c. Now the reason why it is theta c is, when you increase the incidence angle at a point at which the refracted ray becomes parallel to the boundary or normal to the plane, that is 90 degree, this particular condition is called as a critical condition, or the angle is called as a critical angle. If the angle of incidence is increased just beyond this critical angle, you have total internal reflection. That is, you don't have any refractive component, you have the incident signal which is striking at the medium reflected back into the medium. And this is the principle which is used for guiding the light in the core. So now that we have understood the total internal reflection, how the light is guided. So in case of the fiber, you're going to have core with a larger reflective index compared to cladding. So when light strikes at the core, if the light incident angle is greater than the critical angle, then total internal reflection will take place and the light will be guided through the fiber. If the angle of incidence is less than the critical angle, the incident angle, when it enters the core or the fiber, it won't be reflected, it will be refracted. So there is a signal loss. So now that we have understood this, here is a question. So can you think of any two advantages of optical fiber communication considering the need of optical fiber communication, which I've already explained in the previous slides? You can think for a moment and you can note down the answers in your course journal. So here is a list of advantages of optical fiber. First one is the bandwidth. So the fiber optic cables have much greater bandwidth than metal cables. The amount of information that can be transmitted per unit time of fiber over other transmission media is most significant advantage. And likewise you have other advantages such as low power loss, interference, size, weight, safety, security, flexibility and cost. Now all of these disadvantages are considered the factors or which are disadvantages in the case of your traditional communication link, which is using copper cables. So if you see the size in comparison to copper, fiber optic cable has nearly 4.5 times as much capacity as the wire cable, and the cross-sectional area that is 30 times less. So with this, we come to an end of this session. Hope you have enjoyed the session. Please do the activities which are provided in this course. Thank you.